In this video, you're going to watch a senior level engineer answer a system design question of design Uber Eats.
Let me start by introducing myself, and then we would love to know more about you before we jump into the system design interview. Sounds good?
Absolutely, yeah.
Perfect. My name is Danya. I'm currently an engineer at Amazon. Back-end engineer before Amazon. I was at Microsoft. Been in the industry for years. That's me. Would love to know more about you.
Absolutely. My name is Uma. I am currently a software engineer at Netflix, backend engineer as well, basically working in the consumer identity space. Prior to that, I was at Microsoft, like you, and I was in Substrate. So I've been in the industry around 5 years professionally, but counting internships and projects and all that stuff, around 8 to 9 years.
Perfect. Great. So we'll do a system design interview today. Is there a particular tool that you want to go ahead with? Do you have any recommendation for that?
Yes, we could use Excalidraw, if that's
Perfect.
possible.
Yes, we can. Let me start a session.
Yeah.
Sweet. So, our job for today is to design an application or system, something similar to Uber Eats,
Okay.
or you can say food delivery primarily.
Okay.
Yeah, that's what I will say for now. Let's, kind of discuss what you think about Uber Eats food delivery app, and then we'll jump from there, take it on from there.
Okay. So straight off the top of my mind, a food delivery app, food delivery system like Uber Eats, there's a lot that goes into Uber Eats. It's a massive application. So I want to kind of like clarify what exactly we're going to be focusing on today. There's the food ordering part. Before even that, there's this part where you search for the restaurants. Before that, there's the part where the restaurants put in their food and their hours and all that stuff. And then on the other side of that is the drivers who pick up the orders and then destination. So is there any specific part that you want me to focus on for this interview or specific parts?
That sounds great. Yeah. For today, I want us to start focusing on the search aspect.
Okay.
Uh, when we are looking into the deciding the order and restaurants and everything. The second part is for the driver matching,
Okay.
and the third part we can get into the payments. Obviously, these are the three I want to be the core focus of today, today's exercise. If there's anything else, depending upon the time, if something comes up that you would like to get into, I'd be more than happy to do that. But I think this is the three things I want to discuss today.
Okay. Sounds good. So the design focus, we're focusing on the search aspect of Uber Eats. Is that searching? That's for searching for restaurants, correct?
Yes, restaurants and food, what they are looking for. So those two things.
Okay. Searching for restaurants and food. And then for the driver matching, this happens after an order has been placed and the order is ready. Do I have to worry about that link between, the restaurant saying order is ready and then we pick up, we then send it to a driver, or can we just assume that um, the driver gets a notification saying the order is ready and then they go pick up the order, right? But the design is more figuring out which driver to send a notification to and less on how the notification gets to the driver. Is that accurate?
Yes, we want to assume the restaurant sides of the things and focus primarily on the driver matching aspect with the food, with the order.
Okay. Okay. And for payments specifically, um, this is payments. This is the payment for the food itself, and less on the payments for the drivers because there's a lot of payments, right? Okay.
Yep, yep, yep.
Okay. Customer payments. Okay. All right. So um, this is going to be the design focus, but first I want to just briefly list out the functional requirements. That way I can design based on that. So um, functional requirements. So um, we have the customers um, should be able to search for restaurants. Um, customers should be able to order food as well. Restaurants and order and place and order. Search for restaurants and place and order. Okay. Um, The next part of functional requirements is on the other side, which is drivers. So drivers should be able, drivers should receive notifications on orders. And finally, for payments, so the system should be able to process payments.
Yes.
Is there anything else I'm missing or anything that you would like us to add for the functional requirement?
No, I think this is good.
Okay. I want to move to quickly talking about non-functional requirements, which is how the system will behave. For food delivery apps in specific, I'm thinking about the latency for the search, right? Is there a specific number that we want to go for?
What do you think?
Yeah, sorry.
What do you think would be a good?
Um, well, a Google search happens in approximately less than 400 milliseconds. So I'm assuming we would want it to be low latency, right? We don't want people waiting when they order the food. So we'll do low latency for search. In terms of how available we want the system to be, we want it to be highly available. We would rather the system is offline all the time than so highly available. And I'm trying to think of other functional requirements. Let's see. Consistency. So assuming a restaurant updates their menu, it's okay for that not to. Is it okay for that not to reflect as soon as they happen? Right? Maybe meaning the trade-off we'll have for highly available, meaning we always return information to the user, is that some of that information may not be as consistent. So eventual consistency is something that we will have to swallow. Rather, it's basically on the other side. But I would love to get your thoughts on that.
Fair enough. We still would want like some SLA on how quickly we update those things, like the restaurant's open or closed now, or stuff like that.
Okay.
But we can move towards eventual consistency, but with a particular SLA here.
Okay. With an SLA. Okay. We can talk about the SLA in a bit when we're doing the design. Okay.
Yeah.
The next part that I want to jump into, if the requirement looks good, is I want to just briefly touch on the actors, because based on the actors, I'll design specific flows for the service. So for
Before we move forward, I do want you to focus a bit more on the driver matching aspects and the payment aspects in terms of the non-functional.
okay, so in the non-functional requirements, you want me to focus more on the driver matching aspect.
Yeah, we have said highly available systems, right? But
Yeah.
what to do with between for the driver matching and payments, right? There needs to be some sort of consistency that we need to focus on.
Okay. So can you explain that a bit more? I am slightly confused. So you said consistency between driver matching and payments.
As in, so the system should be consistent for the aspect of driver matching, right? Think from
Okay.
this perspective. When
Okay.
the driver matches, right, with a particular order, what can happen? Yeah, so we should focus on higher consistency there, and similarly for payments too.
Okay. Okay. Got it. That absolutely makes sense. Yes. Okay. So for in terms of personas for the system, there will be three, just mostly based on our design, or you can call them actors. The first is the customer. Um, the next, well, for for the specific design, there'll be two, right? First is the customers, and then next is the drivers. Drivers. These are actors. I'm thinking through defining entities for the system, but give me a sec. Let me just think through how I want to approach this. Okay. Okay. So we have our customers and we have our drivers. And right now we have our functional requirements, which are these, and then our non-functional requirements, which are these. It's mostly focused on search aspect. Okay. So I will start with designing a high-level overview of the system, just something to meet the basic requirements before we then dive into the non-functional requirements where we can make specific changes, if that makes sense.
It
If
does.
that's okay. Okay,
Yeah.
sounds good. So moving on to defining how the system will operate. So we'll start with the flow of the customer who wants to be able to search for a restaurant, right? This will be our customer here, customer, and they will send a request via whatever mobile device or web device that you're on. And that request, for the sake of scale, which we didn't talk about, if we should really talk about, how do we want to handle scale? I'm guessing scale is we want the system to be very scalable and thinking about the different regions as well. Is that something that we want the design to account for?
So when you say different regions, could you elaborate more?
Scale. I mean, if the system is going to, if the food delivery app is only going to be available in one town, right? Then the way I would design it would be different from if it would be available in the whole of the United States versus the whole world, right? And that's the type of scale that I'm thinking about. Yeah.
Fair enough. Let's focus on US for that matter for today,
Okay.
rather than the whole world.
Okay.
Yeah.
Scale. Just out of here. All right. Scale focusing on the US. So I'm going to design the system as a series of microservices. And for that, the way I'm thinking about it is the customer will make a request, and since we'll have a series of microservices that handle different things, each one of those services will scale independently to be able to handle traffic loads, traffic spikes, depending on when they happen. And all that request will go through a load balancer, stroke proxy layer at first to figure out where to send specific requests. So this would be a load balancer. Here, I'll put a load balancer in front, and that request will go there, right? So assuming we already have a database assuming we already have the database of the restaurants and the menu, and sorry, the restaurants and the menus here. We will have that here. So we'll call it DB for restaurants. DB for restaurants and menu. And this database for the restaurants and the menu it'll probably be a NoSQL database, mostly because we're only in the US. We want it to scale properly, but we also want it to scale horizontally. And NoSQL databases scale better horizontally. We also don't need some of the ACID principles that the SQL database gives us. So assume that the restaurant menu would be a NoSQL database here. And so we'll then have a search service here where we'll have a search service where this request goes to. And then from there, the search service then goes directly to our database and queries the database, and it returns the result back to the customers. This will fit the very, very simple, basic search for a restaurant, and we return that. But obviously, it won't do it in the fastest time. It won't do it in the best way possible. And for that, we can start to think about some optimizations that we can make. So the first that I'm thinking about is just solely based on searching, right? So if we want very low latency when we search, we can use, there are two ways I'm thinking about it. First, we can use Elasticsearch in addition with the database. That way, there's already Elasticsearch. Elasticsearch. That way, there's already the data here in the Elasticsearch, and we just use that. And so this is now this is the point where I was talking about the latency that we give up because we're now using this to make sure that the search goes faster, meaning whatever data or whatever updates that happen to the DB will have to be recomputed in the next time the search thing then creates. So that then speeds up the search for our database for that then speeds up the search when reaching our search service to search for the restaurant and the menu that then returns that. So the low latency non-functional requirements, the non-latency non-functional requirements and the customers being able to search for an order has been fulfilled. Do you
How
have
would
any questions or thoughts about that?
yeah. How would you ensure the freshness of the data here while using the Elasticsearch?
How would I ensure that the data doesn't go stale while using Elasticsearch?
So, for example, we are talking about the restaurant closes or the menu changes, pricing changes, all that kind of stuff. How
Yeah.
would that like?
So off the top of my mind, I'm thinking it'll have to be we would have to either recompute,
Okay.
basically have a figure out what time figure out a time frame for us to recompute this thing here in a way that doesn't cost millions because each time we recompute it gets expensive, but at the same time also make sure that the data in there is fresh and it's not stale. I think probably figuring out, doing some sort of study or some sort of analysis on how often how often certain restaurant menus change, and then using that to then inform how often we then recompute and then update our Elasticsearch. That's how I'm thinking about it off the top of my head.
Okay. Sounds good.
Okay, so for the next part of the functional requirement is placing an order from the customer. So in this case, I will have a separate service to place for order placement. Let's just say order service. So this service would be responsible for basically taking orders. So the customer has basically seen all the restaurant, they've basically figured out what they want. Now they're gonna reach out to the order service to place an order. Once that order service is placed, that message needs to go to a few places. First, it needs to go to the restaurant that then makes the order. We also need to, even before that, we do not want to send a message to the restaurant before we collect payments. Otherwise, we end up with broken processes. So we need to send a message to a separate service. Let's call that the payment processing service. There are two ways we can go here in this instance. We can either choose to do it our own way, meaning we create our own service that handles all that stuff, or we can use an external third-party service like Stripe, for example, and they help us process the payments and then handle all of that. So again, depending on how we want to do it, the payment service will handle payments for the food ordering service. Is there any, I know you wanted us to focus on the payment processing aspect. Is there anything specific you want me to dive into here?
What are your thoughts on how would we process the payment service? Right? Are we using a third party? Do you have a preference? Yeah.
That's a good question. So there's two ways you can go about it, right? There's if you want certain customizations as to how specific things are done, how retries are happening, and how the system handles failures and a bunch of other things. And certain if you want as much customization as possible, then you typically want to do it yourself. But that also comes with the overhead of having your systems designed a specific way to meet the audit requirements of those payment services, right? Visa or whatever bank card isn't just going to allow you call your thing with just your simple service. You have to go through a lot of work to figure that out. And on the other side, if you do want to move fast, you can use an external payment service to help process the payments. They already handle all of that. All right. And so, like I mentioned, something like Stripe. So it all depends on which way you want to go. I personally would leave all of that to Stripe or some external service because I am not in the business of processing payments. My business is mostly the food ordering part of it, and so I would leave that to the people who know most of that. That's how I would think about that.
I think that sounds a good idea. Yeah, let's use a third party payment system such as Stripe.
Okay.
Um, yeah.
Okay. One thing I do want to note though is that we want everything that happens in the payments processing flow to be very consistent, meaning we want to be sure of a response before we then go to the next step. So the calls between these services would be synchronous instead of asynchronous. So when we send a message to the payment processing service, first we create an order record in our record database, which I will create right here. Order database. Database. This would be a SQL database because we want the ACID principles. And so we'll create a record here. And the record in the order database will have specific statuses, right? Like the order is pending, the order is paid, the order is delivered, and all that stuff. And so what would happen is once the payment processing goes through, we can then update the order in the database with the status of the order. But all of everything that's happening in this flow is synchronous and not asynchronous, if that makes sense.
It does. It does. Okay.
So the next part of the design is the driver should receive notifications. And you wanted us to focus specifically on the driver matching and the consistency there.
I think let's skip the notification aspect, but I don't know if by when you say notification, you mean the notification system. I just want to focus a bit more on the driver matching aspect of the entire system.
Okay, got it. On the driver matching aspect. So this is, let me just move this here slightly a little. The driver matching. So in this case, we will have our second personas, which are the drivers. And then they will be on their app and they would be connected to a session. So I'm thinking about using a driver session similar to how. So typically we've used a request response model, but in the sake of the driver, thinking about having them connected to sessions. Let me think through that a little bit. The general idea is that there could be a stream of notifications or a stream of events that are happening to say, hey, there's this order in this place, there's this order in that place, there's this order in that place. And instead of, I would like the messaging between the driver and whatever system that processed that to be real time and not based on a polling mechanism where send a request or you send things back. And so I will just put that layer right here underneath, right? So for now, we'll just, yeah.
For the simplicity of this, let's say the driver does not have an option to accept or reject it. Okay. So let's say if they do get a request, if they're online and if they do get a request, let's say for the today's session, they generally accept it.
Okay. So there's now an order service, and the driver gets sorry, not order service. Give me 1 second. Let me think of a name for this. So the drivers receive a notification for service, and you want us to focus on the matching aspect. So for us to focus on the matching aspect, I'm thinking about two certain things off the top of my head. The first is we need to know the location of the driver, right?
Mhm.
We need to know where they are at all times, which again, that'll help us using the open session as opposed to the request response model, using probably web sockets to connect to that session is going to help us. And next, we need to know we have our list, we have our order database here, which is a SQL database that where we have a list of specific orders, right? We'll basically have an order processing um, orders delivery service to basically kind of when an order goes from in progress to completed, right? Say the restaurant says this order is completed. We then want to send an event as opposed to a message to our delivery service, which will then work on trying to figure out what the best driver is. Rather, maybe it could be the closest driver. So now I'm basically trying to figure out how we'll then, say how we'll select a driver. It could be based on location, and I'm also thinking about what other aspects we can use. Um, the easiest would be location.
Yeah, I think that's something certain. We should use it by location. Yeah.
Okay, so the delivery service will then match with the driver based on location. There's optimizations that we can make where, um, say, multiple drivers are going in the same direction, right? If you know the location of the restaurant and you know this order is ready at this time and then the driver is going to pick up an order here, they might as well pick up an order here. But we also have to factor the customer's location too in mind, and then we will basically use all of that in the delivery service to try to figure out how to match the drivers to specific orders from our database to then deliver those to the customers.
Walk me through how this entire, like, how do you know where the drivers are? How are we storing that? How are we ensuring the order is only matched with one driver, right? One-on-one mapping, all of that stuff. And keep in mind, this needs to be fast enough, not as fast as the low latency, right?
Mhm.
Like in the search, but it still needs to be fast enough that we can match orders and drivers.
Okay, so I'll break it down into. I think you asked three questions in one, so I'll start with the first one. How
Yeah.
do we, how do we know the driver's location at all times? That's a good question. I would probably have a data store to keep track of that. And that data store, I'm thinking about what to use for the data store. Um, let's say driver information, driver location data store. So I'll have a driver location data store. This data store will most likely um, it'll be updated with information from the drivers as they move, and the delivery service is going to read that to figure out which drivers to pick and choose to then send the order to. I'm thinking about optimizations I can make on the driver data store. It'll be read a lot. It'll also be written to a lot, and so um,
What are you storing in this location? Like,
Um, in the data store, so it'll be changing. So I'm thinking of it'll be changing frequently. We can store their addresses because that'll change the latitude, probably the latitude and longitude, which is their exact location. Um, longitude, and we will use that in addition to the latitude and longitude of the restaurant to figure out where to send them to. Um, does that answer your question?
yeah, it does. One more step of food for thought here. So let's say you
Mhm.
are storing a lot of let's say there are few hundred thousand um, a few 100,000 in US, but few drivers in that particular area that
Mhm.
you're looking. This system has all those 100,000 drivers and their locations. Like, how are you saying? Okay,
It doesn't have all of them. It has the ones that are in session, right?
okay,
So it would be like if you're at home and you're not in the process of actively delivering, then we don't need to store your information, right? But if you're actively delivering and you're online, then it would store your location or your last known location. Yeah.
fair enough. Let's say even 50% of them are online, right?
Mhm.
Let's say you are in Seattle or West Coast. Let's even take Seattle. That's where I am. Do we need the location of, or do we need to even filter for the location of people that are in New York for that matter, right? Like what I'm trying to say is, in terms of efficiency, how can we further improve the system of figuring out what those subset of drivers are?
Yeah, that's a good question. So we can shard this. You can shard this based on geo locations where we have shards based on we can do it based on cities, but if we do it based on cities, then there's some orders that could go from one city to another. So we could basically just use a geo sharded database, or we could geo shard their locations based on where they are. That way, request for from the delivery service only hits the database or hits the shard that the drivers and the restaurants are located in.
Okay, sounds good for now. Yeah, let's
Okay.
move forward.
Okay. What was your second question in your chain of questions?
The second one was, how do we ensure that only one driver is matched with one particular order?
Okay. That's a good question. For that, we have to keep some. We basically have the state of the data, or rather, we have the state of the order in the database. We also have to keep track of the state of the drivers in which orders they are currently assigned to, or which orders we have assigned to them. And before we assign an order to a driver, we check if that order has already been assigned before we then assign it to a new order. Or we check, we could have a separate data store to then, okay, let me step back. If we store it with the drivers, then we then have to check a driver every time, as opposed to storing it by itself, right? We can create an association of orders with drivers. And so that if a driver cancels an order, we just remove that driver from there, and we know that this driver, there's no driver currently linked to this order. And if we now want to assign a new driver, we just assign it. So it'll be like a 1 point query instead of going to find, um, yeah, it'll be a 1 point query where we just pick an order from that order to driver database and check. And if they are matched, good. If they aren't, then we know we can assign. So we never assign multiple drivers to one order since we already keep track of that.
Okay. While we so when the order gets placed, right, like
Mhm.
places an order,
Yeah.
it is there's a record created. Let's say the restaurant somehow says, oh, that the order is ready to be picked up. At that point in time, you provide a notification for that particular order to the delivery service, right?
Mhm.
Now, do you select one driver to provide that information to? Do you select multiple drivers? Like, the selection of the drivers are happening in what particular way?
Yes. So let me just put this here. It'll kind of be our driver um, order store. So the way I'm thinking about it is it'll come to, we'll basically have, we will write the order to this store, right? Hey, this order is ready to get picked up. Our delivery service will also work with this to figure out whether the driver or not, because it's whether the order currently has a driver or not, right? So my thought process is the the delivery service will look in our database here, right? Who has who is closest, right? Run. our algorithms to figure out who is closest, the most efficient way, and it'll send that to the driver to say, hey, there's this order from this restaurant. Does the driver accept? If the driver accepts, great. We send that back to the service, which then updates this to say this driver currently says he's going to deliver this order. Then we can now have a notification service that then sends it back to the customer saying, hey, this person is going to pick up your order and they'll be, at your door in X amount of time. If at some point in time the driver can't pick up that order anymore, or if some time goes by, or if the driver cancels, or if something happens, we simply then update this data store to say this order no longer has a driver attached to it. Yeah.
Okay. Let's say for that that doesn't happen in our in our day to day.
Okay.
Assuming that, right?
Yeah.
Now, if the driver is attached with the order, it
Yeah.
comes an order in that particular restaurant or nearby, where that particular driver is still in that nearest location.
Mhm.
Do you provide them another order because they already have an order? I don't like, how do you handle that situation where if a driver already has an order, they are
Mhm.
not assigned another order?
Well, I'm thinking about so the constraint that we have here is that a driver can only have one order.
Sure.
Okay. So here we have so I'm thinking about two ways. So we can create a reverse index table, which is just the opposite way, where we now have a driver to an order, or we, based on what we're storing in the driver's, as part of the driver's information, we can also store if they're currently in the process of delivering an order, right? If we have something assigned to them, and then we can then use that as a check, right? There's multiple ways we can do it. There's what I've mentioned, or we can just if we're worried about speed, because here, for example, this is meant to be order driver. My apologies, order driver, and then we can create a separate one for driver order, where if we could just say this driver, do they have an order? Of course, now we have two distinct things. We are writing twice whenever we are updating, so that'll have some cost there. If we, depending on how we design them and the locations, we're basically duplicating the data store and all of that. But that's basically how I would think about designing that, where a driver only has one order. We basically have a state of what they're currently assigned to, and we check that before we deliver them. If we want the constraint of one driver to one order at a time. Yeah.
Okay. One last question before we move away from this particular driver topic is
Absolutely.
we are updating the location of drivers very frequently, right? You said
Yeah.
this is very read heavy as well as write heavy.
Yeah.
Um, are there any optimizations that come to your mind that would help us in terms of the way we are writing the locations of drivers to this particular data store?
So optimization specifically to the right of the drivers to the data store. Let
Mm.
me think.
Because we're writing their location, right?
Often, yeah.
What possible cases do we need to write the locations? How frequently do we need to write these locations? I wanted to think along those lines.
How often we need to write the locations? Well, we need to write the locations when, typically when, well, we don't have to write it every minute or every second, right? That's
Mhm.
definitely overkill. At the same time, if a driver is in a general region, for example, say they're in Cap Hill, for example, right? Um, Technically, we don't want to. Sorry, I use Cap Hill because
I know,
we're both in Seattle. But say they're in like a specific area within a town, we don't need to know that they're still in just one part, maybe First Hill versus Cap Hill, right? But if they move from a certain location to a different location, then on the client side, we can then update that. Where since rather on the client side, we can watch for that, and if that happens, then we update their location. So instead of updating frequently, maybe every that's sorry. So on how often it needs to happen, it doesn't need to happen often. It will only happen when there's a big shift in from their previous location, from their last known location. So the client will compute that and only send it if there's a big shift.
Sure. Okay. Okay. Sounds good. And one quick question I have regarding payment processing service.
Yes.
We need to ensure, again, the consistency aspect of it.
Yes.
What things come to your mind in that regard for payment processing?
Um, First one that comes to mind for payment processing specifically is, I think I mentioned the first one. It needs to be synchronous, so we need to be sure that the payment goes through before we complete. Consistency. Um, I'm thinking of idempotency. So if there's if you're trying to place the same order within a certain time span, we should have some sort of logic in there to make sure we're not double charging you for the same order for the payments. Those are the two that come to mind.
Where are you creating that idempotency key?
Idempotency key will most likely happen in the payment processing service, right? So where the service receives the thing to make the payment. No, sorry. Idempotency will happen on the client side. My bad. It'll happen on the other side. So customer creates that key, and then on the processing of that specific thing, we store that key. When if it happens again using the same key that we've seen, then we know that it's the same thing, and then we can process it in two ways. We can send back a message to the client saying, "Hey, it seems like you've already paid for this," or if it's the exact same order, we can just make sure we don't duplicate that order in the database and we don't charge the client.
Sounds good. Anything that you want to mention before we wrap this up about this particular system that we have?
I just want to go through the functional requirements real quick to make sure the design fits. The design solves for the functional requirements. So drivers receive a notification. We did that. Customer should be able to search. We use Elasticsearch. System should be able to process payment. It does that. Eventual low latency for search. Eventual consistency with an SLA. We didn't talk about that SLA. We did. Sorry. We'll basically figure out how often the data changes and then figure out a good way to compute. Obviously, we can't compute every hour, but we also can compute every minute. So it's basically finding that balance. High consistency for driver matching. We discussed that. And scale using microservices. Each one of these would be individual services that can scale up or scale down based on demand. So yeah, I think that's all I have for now. Yeah,
Perfect.
thank you.
I really appreciate your time. Thank you so much. And it was great doing this exercise with you.
Absolutely. Appreciate it. Thank you for your time.
Let's just start high level. Danny, I'll ask you second. I'll ask you first. Uma, what did you think of that candidate? Just high level overall, what comes to mind about how that candidate did? Yeah.
I think the candidate did well. I think one thing that stood out just from a general perspective is making sure that they designed for what was asked, right? So clarified requirements and making sure at the end of the interview, everything that was asked was what was on the design. Maybe some may not have been the most optimal, but at least the candidate basically checked off all those boxes.
I thought it was really interesting that the candidate, after completing the design, then came back and said, now let's look back at the non-functional and functional requirements and see if I did everything. Yeah, I think that was awesome. Awesome. Danny, high level, what did you think about how the candidate did? Whatever strikes you. Yeah.
No, I think the candidate overall, I felt like was knowledgeable enough to kind of understand the system, understand the different aspects. Something very interesting, or I think great in the beginning that occurred to me was how they were very communicative and trying to understand or trying to get into the interviewer's mind, right? When at the
Yeah.
very start, what do you think we should be focusing on today? So I
Yep.
think that's a very good technique because at the end you want to focus on things that interviewer wants to listen in that 40-45 minutes. That's a very important aspect. Not just go off what you're thinking, but also make sure that you are on the same page with the interviewer. I think that was a great start where I could kind of lead. So the candidate was leading, without it seemed that they were in control. It seemed the interviewer, whatever the interviewer wanted was happening, but I felt the candidate was still in the driving seat by just asking those questions.
100%. I felt that you were being both a leader and a collaborative partner, which is a hard balance to strike. One of the interesting um, language choices you made throughout the interview, which I also liked, was you would say, I'm thinking of this, and then I'm thinking of this. And then most times, maybe a few seconds later, you would say, let's go with this for this reason. So just in terms of like people that are watching this to want to understand like, senior level skills, like when we talk about trade-offs, there's really only a few boxes somebody needs to check to be seen as senior. And one of them is trade-offs. And an easy way in a system design interview to get there is to look at two different choices and then reason your way through it. You have to be vulnerable enough to tell the interviewer, because Uma, correct me if I'm wrong, but a lot of the times when you started saying, how would you ensure the data is fresh when using Elasticsearch? Like we could recompute it every time, or we could do it another way. When you probably said it out loud, did you know which way you wanted to do it?
Not really. So at that point in time, I was just going through all the options, right? Like you said, there really isn't a perfect. There's no right answer, right? But
Mhm.
this is one way we could do it. What are the trade-offs, right? It could be way more expensive. It could take way more time, but are we delivering this, right? And that's why the candidate was always going back to the interview, right? What do you care about, right? What do we want to focus on this design? So yeah.
As experienced interviewers yourself, what are some common red flags that you see just when candidates make a decision on a component in the design? Yeah.
Um, I could go first. The first I've seen is for everything I mention or for everything that I typically say, I try to say why I'm saying it, right? So you could say there's Redis, there's Memcache, there's all this. We can use this database, we can use GeoDis, we can use that. But a lot of times, if you don't justify it or if you don't say why you're doing it, then it just sounds like it's a buzzword that you heard somewhere. And
Yeah.
so that's a red one. I know it can be tricky because not a lot of us have had opportunities to work with those things. But again, studying the um basically doing more research into where this fits and why it would fit. That way, when you use it, you're using it in an informed way, as opposed to just say, we'll just put a cache here. Well, you could
Right.
put a cache there, but if your cache is going to result in more cache misses than hits, then why do you have a cache there in the first place? You're just costing way more money. Yeah.
Nice. Danny, what do you think?
Yeah, I think I'm on the same page. I think I say this as this particular system design interview is like you're a lawyer defending your decisions, right?
Yeah.
It's basically you're providing justifications of why you are trying to do. And again, sometimes you might not get the optimal answer, and that's all right, because as you start to work, 5 years of experience, 7 years of experience, there's only much you have worked in, right? Like if I haven't worked in payments, I wouldn't have, if I hadn't gotten an opportunity, I would not know a lot about payments. And that's all right to say in an interview that, hey, this is the extent of knowledge I have about the system. But
You did
if
that as well. I like that a lot. Yeah.
if given at a certain point, I have to, I can deep dive into this. But showcasing those abilities is what makes you senior and above level engineers. And going back to a specific example in an interview, in this particular interview, I think when Uma was talking about data stores for driver matching, initially there was an idea where he wanted to use probably a DB and update the statuses of them, and then suddenly he said, if we want to go for speed, we can use a data store. I think that was a great example that, okay, there are two possible answers. However, based on what we are trying to optimize, we can go for one end or the other. So still two answers. I like the second one better, but again, the fact that the candidate provided two different answers and could defend both is a lot of times what would eventually happen in an actual situation too while you are working at these companies.
That's so cool. I had a brand new thought that I've never had before about system design. There's basically like three choices that you can make when you have to talk about a component. Number one, you can say, and this is for stuff that you know well enough, like Uma said, hey, we can choose this here, and we're going to do this because it's faster. I think it was about storing something in the database to the driver or just storing it on its own. That was really smart. Okay, so if you know it well, that's your choice. So make the choice and give a brief rationale. If you don't know it at all, the second choice is to lower the stakes. I'm really not a payments processing person. When somebody says that, the interviewer's bar for success now lowers. It's counterintuitive because you don't, it's like vulnerability, like
Mhm.
vulnerability in a system means the system is insecure, but vulnerability, like socially, just means you're sharing something that you're not great at. And it's actually smart. It's just like saying the word I don't know. Some interviewers literally will wait for you to say the word I don't know. And if you don't say it, it's a box you're not checking. So those are the two first tactics. Make a choice and defend it briefly, or secondarily, lower the stakes and say, I've never worked on something exactly like this, but here's what I've been reading about, or I don't know if this is 100% true, but here's what I'm pointing towards. Those are smart things. But the third thing, and this is where it's kind of nuanced, is hand waving. So you did a few hand waving things here, and senior engineers hand wave things all the time because, for example, we're talking about how to match the drivers with the restaurants. And what you just said, you mentioned it once, it was very smart. You just said something like, we got to run our you kept it a black box. You didn't dive into it. It's 45 minutes. You cannot describe what Uber Eats had dozens of engineers working on to make the algorithm. So smartly, you avoided that, but you got over it to save time. Can you guys get all to this idea of hand waving things and just how you think of hand waving things as a candidate, as a strategy?
Yeah. The way I think about it is if you know of it but you don't know enough about it, right? You could just say it at a very high level. Because what I've found in the past is if I now want to start talking about, oh, we'll use this algorithm, I don't know enough about machine learning to even figure out how to train a model or how to do all that stuff, right? So I know from experience that there's some sort of thing that happens there, and it's way more complicated, as you said, and it may take more time, and I don't know it enough to give a good impression of my knowledge about it, right? So why would I dig myself in that hole?
Yeah,
So I just mentioned like a quick high level, and if they then want to dig in deeper, maybe this could be a machine learning systems interview instead of that, then that's where you can do it, right? But the other part of it is also knowing when to do it and when not to do it, right? I just mentioned in a systems design, sorry, in a machine learning interview, that's probably what they're going for, right? So, but in this case, it was just more designing these systems and how they communicate with each other. So in situations like this, it's a little bit okay to just hand wave again, provided that your interviewer is okay with that.
yeah. Choose it
Yeah,
selectively, basically. Love that. Yeah.
100%. No, I think yeah. It's always good to know what your limitations are in an interview, and
Mhm.
this also happens. If we kind of corresponds to your actual day work. A lot of times when I am given a task, in my interview, in my actual coding or working journey, it's like you go research about it, you come back because there are things that you wouldn't know, and as an interviewer, I do also understand that when a candidate says, "I I will choose, let's say a particular, I will choose Postgres because I've only used Postgres in last 3 years, so
Yeah.
I'm just comfortable with that," and that's a fair enough answer.
Yeah.
And say if I had to make an actual decision, there will be a lot of research go into, but this is why I'll choose Postgres, and that's a
Uma,
fair answer.
if you were the interviewer, Uma, what would you think of a candidate saying that?
Absolutely. Yeah. Like it's again, you mentioned this in the beginning. It's not a you and the interviewer mentioned in the beginning. It's not a right or wrong, right? It's just can you build something that solves the requirement right now? And based on what you know, right? Based on what we've given you, right? Does it solve? And then from there we can start designing and then making optimizations. Yeah. Mhm.
I have this theory.
Mhm.
There's red flags and there's green flags, and then there's kind of like a step up from green flags, which is kind of like the word that kind of unlocks the candidate from the perspective of the interviewer as being like, oh, they get it. And I know I'm doing one of those annoying things that interviewers do, where I'm going to ask you guys if you guys noticed what I noticed and try to just see if you noticed it. But there was one moment where Danny got really excited when you said a word at the end, and then Danny asked a follow up question about that word. I can tell you guys exactly when this was for me, but just we're
Mhm.
talking about how to make sure the payment processing is consistent.
Idempotency.
Yeah,
I
Danny,
think
can you tell me what your reaction was when you heard Uma say that? If you expected it, if you had follow up questions you wanted to ask about that, just as your interviewer mindset, can you kind of peel back the curtain a little bit and tell me what your reaction was upon hearing that?
That was exactly what I was going for. Number one, like I wanted to understand, like this is a concept generally used at various different levels, not just payment processing. But that's why I to bring this up in an interview. That's one. Second, um, the idea of where this follow up question was, where would this be generated? Whether it would be generated on the client side or would it be generated on the backend scenes? That provides me an understanding about the candidate, that they have this full picture understanding. Why exactly would something happen? The candidate said this will happen in payment processing service, but I think upon further, and I think they were doing it by themselves. Like few seconds later, they were like, no, this will happen on the client side of things, which was what I was going for. And again, that just gave me an understanding that this person can talk about, can see that entire flow suddenly, which is important when given a task in an actual job as well, that they can start thinking about different pieces, a lot of vague pieces initially. And again, all my questions, all whatever I try to do in an interview, when I'm asking, I'm kind of thinking about how would that correlate to an actual setting. So that gives me an idea that okay, this person can go from point zero to point n given such a vague concept.
Was this a gate you wanted him to get to?
Yeah, 100%.
Right. How many gates did you have in this?
I think a lot of all. So there were, as at the very beginning of it, I said there are three things that we want to focus on:
Mhm.
searching. The gate was Elasticsearch or something very similar. That
Nice.
was one. For the driver matching, there were a lot of discussion that happened. That was the crux of the interview today.
Mhm.
There was, I think the candidate almost got to the geo-hashing aspect of it. I had to kind of probe the candidate to go into that direction.
Mhm.
That was something I was wanting for them to ponder over and understand and kind of think how they are thinking, or, can see the actual picture. And
Right.
then the payment was the idempotency key. So these were the three things. Again, at
Right.
every instance, you could go further deep dive depending upon what they are looking for. So I've kept it open enough that they can kind of go where they want to,
That's
but
sick.
it's like what's the word, it's like once we start going deep dive, then I want to check their depth of their understanding.
What about this choice that the candidate make at the very end? I'm done with my design, and it's a confident move to say, "Hey, let's go back, check the requirements, and see if I hit them." Can you guys speak a little bit to like maybe in what situation this works, and then maybe in what situation you maybe might not want to do this as a candidate?
Yeah, I could go. So, as a candidate, the way I think about it is when I'm interviewing, I want like you're asking me to design something, and we figured out we both agree that this is what I'm going to design, right? And if, as I'm designing to, if as the candidate was designing to, if you noticed, he looked back to say, okay, the first flow, this was done, right? We've checked
Mhm.
out number one. The second flow, we've checked out number two. We've checked like, and so um, I typically like to do that just to make sure everything is clear. And for the parts that I didn't have time to hit on, I
Nice,
then have an opportunity to give a high level description of how I would do it, right?
nice.
If I didn't have time. So it's it's something that I would suggest you do just so if you never get to a place where I get to talk about sorry, if you never go to a place where you got to talk about something that the interviewer is going to use as a gate, you can quickly mention that to know that, oh, okay, they
Mhm.
didn't have an understanding that they understand this just because you didn't have enough time to design it. So that's typically how I think about it.
I love that. I love that. It's a new tactic to me. I've never seen anybody do that, and I really, really liked it. Yeah. Thoughts? Any thoughts on that choice, Danny? I think Uma summed it up well. But any thoughts?
I completely agree. That being said, I build on top of it. My way of doing it, like if I was the candidate, I do it multiple times, because like as a in a
Mm,
scenario where you have missed few things that are important
mm,
at that last minute, it might also highlight what you've missed. Suddenly that is also left in the interviewer's mind that okay, we couldn't go through these, so that can
mhm,
also backfire. But as a strategy, if you continuously do that during an interview where you're like, okay, we just hit this mark, let's move on to the next one, we hit this mark, let's move on to the next one. I always do it. Just at the last minute, again, in this case, Uma had covered majority of the things that we were trying to. It worked out well, but it could, if you're continuously doing it, I think that's a great strategy, because now if there's some, like you're going off of the interviewer's energy as well, right? You're
yep.
like, I'm about to move into this particular topic, and I'm continuously taking feedback from my interviewer. Are they excited? I'm looking at their facial expressions, what they're trying to say, and just navigating as I'm moving forward.
Yeah.
So, though, if you continue to do that throughout the interview, it will definitely help.
I just want to notice if people go back and watch how excited Danny got when Uma said idempotency. It was like he was like nodding like so hard, like he hadn't nodded that whole time, the whole time. So if you see your interviewer who hasn't nodded much the whole interview, if they're nodding vigorously, you probably just got through a gate. So stay there for a little while and explore that area so you can actually flex those muscles. So I know it's hard to notice social cues and facial features for everybody, but nods are very obvious when they come out of nowhere as composed to most of the interviews like this. And then you have a big, big, big nod. So great.
One thing I quickly want to mention, which I think helped me when I was learning, and then for a lot of people, is I think you come into these interviews and the problem is huge, right? Then you break down the problem, which a lot of people do very well. But then even after you've broken it down, you still think, oh, I have to design the most efficient searching, right? You notice what the candidate was. They like what's the simplest search I can do, right? Let's start with that. Always start with the simplest, and from there, obviously, it's not the most efficient. How can we make it more efficient? We put Elasticsearch. We pull this. We'll pull that, right? So if you always start with the simplest flow, then you have a base, right? At least the interviewer knows you know how to design something that simple, and then from there you can add a base. So that's something that I suggest everyone does, even the most complicated features, right? Start from the base and then start making optimizations from there. But if you start thinking, oh, where can I pull in Elasticsearch? You won't know where to pull it in because you don't know where the data store is because you never figured that out in the beginning, right? Yeah.
Heck yes. Danny?
I think for candidates, like one of the things that I do is, or I would recommend anyone, your root force is your functional requirements. Yeah, just going back to your lead code kind of strategies or data structures. As soon as you say the simplest flows, as Omar mentioned, that if you're doing searching the basic flow, suddenly you did the function requirement. The next function requirement, the basic ones. Your non-functional are the optimizations. If you have put down your functional requirements, you have covered the problem. Now we are talking about optimizations, which are where the deep dives happen. So if you, I think within 5-7 minutes, if you know how to draw the load balance of the client and all the flows, you will be done with your functional requirements. So that's a very interesting way, and a very speedy way of saying I've done the basic problem. Let's talk about it and get into the deep dives. So I think that's a very someone taught me this, and I'm just kind of elaborating on that.
Beautiful, beautiful. Okay, Danny, what's your rating for the candidate? And if you have any thoughts about leveling, would love to hear that too.
Yeah, I think obviously the interview went well in terms of the things that I wanted to cover. So it will definitely be a higher. That being said, my only concern came through the depth of few things where I might have wanted to go a bit further deep into things. Where for example, the geo hashing part. I in that particular scenario, I was kind of pushing the candidate into a particular direction. Even at the NoSQL aspect where we were having a discussion, I felt, and again, it's not to say they don't know. There was a you know burst of thoughts that happened in different pauses, which I felt could have been more clearer to things like at this point in time we might have chosen this particular database or that particular database for X, Y, or Z reasons. So the leveling is where I would be torn between primarily senior or mid-level. That's where I would put that. Again, if this was an actual interview, I would put it as a mid-level again, because we are kind of trained to say to be more safer than to be more on the other aspect of the things. That's what I would do.
Cool. Thoughts? Thoughts? Questions?
Yeah, totally makes sense. I think there were some, like you said, the like I knew of geo hashing, but in that moment, I don't know if geo hashing would have been rather. It wasn't the first thing on my mind. Does that
Yeah,
make sense? And so I had to be probed to it. And so, in terms of successful interviews, it's okay if like my whole goal was to make it a collaboration, right? Where
Yeah.
this is how I'm thinking about it, right? I was saying everything I was thinking, and then eventually, if you're like, oh, let's make optimizations for this, and I'm like, okay, if we're going to optimize for this, we can use geo hashing, right?
Mhm.
I'm also sometimes wary of over optimizing or over engineering. All right. and I only certain or mention specific things if we need it, if it's part of what we want to accomplish. But yeah, I completely agree with his analysis. I think there were different places where I chose SQL versus NoSQL. Maybe I could have done a better job of explaining why. But yeah.
Awesome. Well, guys, great stuff. I know everybody learned something watching this. So until next time, see you later.